In this video, we are going to discuss the structure of fructose. Structure of fructose. The molecular formula of fructose is same as that of glucose. So, the molecular formula of fructose is C6H12O6, and fructose belongs to ketohexose. Ketohexose, which means the functional group present in fructose is ketone, and the ketone functional group, that is C double bond O, that is present at the second position. And hexose means there are 6 carbon atoms in fructose. And the reaction shows that the fructose, in fructose molecule, the carbon atoms are arranged in a straight chain. So let us draw the open structure of fructose. The open structure of fructose is we have CH2OH. So this is the first carbon. Second carbon we have C double bond O. Then first carbon, second carbon, third, fourth, fifth, and sixth carbon is CH2OH. So 3, 4, 5, 6. Now in third position, same like in the open structure of glucose, we have OH group on left side of fructose and hydrogen on right side. Then in carbon number 4 and 5, we have hydrogen on left side and OH group on right side. So you can see the functional group C double bond O is in the second position of fructose. Now, fructose is named as D minus fructose. So, fructose is also given the configuration D, and minus sign denotes that fructose is levorotatory in nature. So, fructose is levorotatory with D configuration. Now, a cyclic structure is also possible for fructose, and the cyclic structure is formed by the addition of OH group on 5th carbon to the functional group, that is C double bond O. So, cyclic structure is formed by the addition of OH to from the 5th carbon to the carbonyl group, which means that again, like glucose, fructose also exists in alpha form and beta form. They are the cyclic structure of fructose. So we are going to draw the alpha and beta forms of fructose. The alpha form is we have carbon, then the second carbon, first carbon we are going to write here CH2OH. Now here we have the double bond of the second carbon breaking and hydrogen of 5th carbon added to oxygen. So we have COH, and this is first carbon CH2OH. Now we have the rest, third carbon, 4, 5, and 6th carbon we have CH2OH group. Now third carbon we have OH, H, fourth carbon H, OH, 5th carbon hydrogen. Now after hydrogen of OH is added to C double bond O, we have oxygen that will be linked like this. So this is the structure of alpha D minus fructose. Now let us draw the structure of beta D minus fructose. We know that alpha and beta forms, the difference is around the configuration of first carbon. Now here we have the difference in the configuration of second carbon, because the second carbon we have the position of OH group on left side in beta fructose and CH2OH on right side. Or we can say in the position of first carbon we have the difference. So I am going to show the structure of beta D minus fructose. So we have here second carbon. Now on this side we have the OH group. You can see here. Then next on right side we have CH2OH group, that is the first carbon. Now 3, 4, 5 and 6th carbon CH2OH. 3, 4, 5. Now here third carbon we have OH, H, fourth carbon HOH, fifth carbon H, and we have the oxygen linked to the fifth carbon. So this is the structure of beta D minus fructose. So we can say that the cyclic structure of fructose also exists in alpha and beta form. Now next we have the Haworth structure of fructose, or we can also call that as the furanose structure. So Haworth structure or furanose structure. Now the structure is called furanose structure because the cyclic structure can be compared with the structure of the compound furan. Furan means it is a 5-membered compound, heterocyclic compound with 1 oxygen and 4 carbon atom. And the structure of furan is like this. This is the structure of furan. Now we can draw the Haworth structure or furanose structure of fructose, alpha fructose and beta fructose. So for that, I am going to take this cyclic structure. This is of alpha D minus fructose. Now we are going to draw the Haworth structure of fructose by looking at this cyclic structure. So we have oxygen here and 1. Now whatever is written on left side will be written on the top. So we have here CH2OH, CH2OH, and this is our carbon number 1. So this will be carbon number 2, 3, 4, 5 and 6 we will write. Now we have down OH group. Now third carbon we have OH, H. Fourth carbon HOH. Fifth carbon we have H and CH2OH. So that CH2OH will be written on top. So this is our 6th carbon and hydrogen at the bottom. So this is the structure, and the name of this compound is alpha D minus fructofuranose. Now let's draw the beta, the furanose structure of beta D minus fructose. So this is our beta D minus fructose. Let's draw the Haworth structure of fructose of beta D minus. We have oxygen. Now here we have OH on the top and CH2OH, which is our first carbon. This is our second carbon, third, fourth, fifth. Now third carbon we have our OH and H. Fourth carbon HOH. Fifth carbon we have hydrogen and CH2OH. That CH2OH will be on the top, which is our 6th carbon, and hydrogen at the bottom. Now you can name this as beta D minus fructofuranose. So these are the 3 structures of fructose. That is the open structure, then we have the cyclic structure, then we have the furanose structure. So with this we complete the structure of fructose. Thank you.